Let us see why we cannot classify the points which are not linearly separable by single perceptron. Okay. So what is the equation for single perceptron? The equation, mathematical equation for single perceptron is summation I from 0 to n wi xi should be greater than or equal to 0 for positive samples, and summation I from 0 to n wi xi should be less than 0 for negative samples. Here for x0 the value is 1, for x0 the value is 1, x0 we consider as 1. Okay, so the same equation can be written like this, that w0 plus summation I from 1 to n w I xi is greater than or equal to 0 for positive sample, and w0 plus summation I from 1 to n wi xi is less than 0 for negative sample. Okay, so for two-dimensional XOR gate, n becomes 2 and here becomes 2. Okay, so this equation is actually used here. These it is used here. Okay, so what are the positive samples here? These are the positive samples and these are the negative samples. Okay, so what is the equation for negative sample? W0 plus I from 1 to 2 wi xi should be less than 0. Okay, and for positive sample, what is the equation? W0 plus summation I from 1 to 2 wi xi should be greater than or equal to 0. Similarly for this, and lastly for negative sample, w0 plus summation I from 1 to 2 wi xi should be less than 0. Okay, so now if we put the values of x in the equation, first equation, we get this. How? W0 as it is plus W1 into 0 plus W2 into 0 should be less than 0, which boils down to W0 should be less than 0. Okay. Similarly, if we put the values here, what we get? W0 plus W1 into 0 plus W2 into 1 should be greater than or equal to 0, which leads to W2 is greater than or equal to minus of W0 here. Okay. Similarly, third equation, if we unroll third equation, if we unroll by putting the values of xi, we get w0 plus w1 into 1 plus w2 into 0 should be greater than or equal to 0, which boils down to w1 is greater than or equal to minus of w0. Okay. Similarly, fourth, if we unroll the equation, we get w0 plus w1 into 1 plus w2 into 1 is less than 0, which boils down to w1 plus w2 should be less than minus of w0. So first equation is very much satisfiable. We can choose any value of w0 which is less than 0. So suppose w0 we select as -1. The first condition is satisfied. Then second condition, w2 should be greater than or equal to minus of w0. So let w2 be 2. So 2 is greater than 1. 2 is greater than 1, minus of minus 1. Okay, so that is also satisfiable. Then third condition is this, that W1 again should be greater than or equal to minus of W0. So W0 we have considered as minus 1. So we will take W1 as 2, again 2. We will take W1 again as 2. So W1 as 2. So again it will be 2 is greater than minus of minus 1. So three conditions are satisfied. But there is a problem with the fourth condition. Once the three conditions are satisfied, we cannot satisfy the values which we fix for the first three equation, and still we can get the satisfactory answer for the fourth equation, because 2 plus 2 now is not less than minus of minus 1. This is not true. Okay, and hence mathematically a single perceptron whose equations are given like this or like this, in general equations are this. Okay, mathematically single perceptron is not capable of handling nonlinear separable data. Okay, nonlinear separable function such as XOR function. We have proved that, and hence we cannot have a single perceptron which can represent the XOR like functions. Okay. Thank you.